Welcome to Pre-Calculus. Today we will investigate dividing polynomials using synthetic division. We'll take a look at two examples. Our first example here is a degree 5 polynomial, 6x to the fifth minus 16x to the fourth minus x cubed minus 20x squared plus 15x plus 1. And we're dividing it by a degree 1 polynomial. In fact, it's just a linear binomial x minus 3. Whenever I've got this arrangement, any type polynomial divided by a linear binomial, I can use a process of division called synthetic division. Now, we've worked with long division in the past, and that, in fact, would work fine. But if you've got a division by something like x minus 3, there's a shortcut. So let's use synthetic division to make this process faster. What I want to do is I want to create a format where I put my divisor in the upper left corner. And what I do is I want to reduce my binomial down to just a number. And the way that I'm going to populate that little corner on the left is by taking the divisor x minus 3, setting it equal to 0 and solving. And that solves very quickly. I just add 3 to both sides. And I see that x equals 3. Now that 3, I'm going to place as my dividing value up there in the corner. And that represents my divisor. Now for my dividend, what I want to do is I want to take only the coefficients and leave behind the variables with the powers. And I'm going to write those coefficients in a row to the right here. So I'm going to start with 6x to the fifth. I'm going to represent that as simply 6. Notice I'm leaving x to the fifth behind. Same with x to the fourth. I'm just going to record negative 16. Negative 1 for negative x cubed. Negative 20 for negative 20x squared. 15 for 15x. And 1 for 1. And then I'm going to leave a blank row. And I'm going to put a operation line there. Now here's the process. I've got it all set up, and now I'm ready to actually run the division. I'm going to start off by carrying down the first coefficient. So I'll draw an arrow, and then I'll bring the 6 down. And I'm going to begin kind of the recursive process to perform the division. I'm going to start by multiplying my divisor 3 by that number I carry down. So 3 times 6 is 18, and I'm going to record that product underneath my second coefficient. And then I want to add them. Negative 16 plus 18 is 2. And that's one full cycle of the process. Now I'm going to start it again. I'm going to multiply 3, my divisor number, by the 2 that I carry down from the sum. 3 times 2 is 6. And then I'm going to add negative 1 plus 6 is 5. Now I'll multiply again. 3 times 5 is 15. I will add negative 20 plus 15 is negative 5. I'll multiply again. 3 times negative 5 is negative 15. 15 plus negative 15 is 0. And then finally 3 times 0 is 0. 1 plus 0 is 1. So I've run the division. All I need to do is make my representation to include now the powers with the variables. So I've made a division by a linear binomial x minus 3. So that means when I replace my variables and powers, the degree is going to decrease by 1 for each one. So what was x to the fifth is now going to become x to the fourth. So I'm going to write the final answer here below. That's going to be 6x to the fourth. And then I just keep that pattern descending by 1 each time. So plus 2x to the third plus 5x squared minus 5x. I could write plus 0. I'll go ahead and put it there. And then for the remainder, what I'm going to write is that value 1 divided by my original divisor, which was x minus 3. And that's how we treat our remainder with synthetic division. And that process is complete. So notice when you compare it to polynomial long division, just the amount of writing is a whole lot less. It's a quicker process, even though we're practicing it here for the first time. It really is a shortcut. Now, it only works when this divisor is a binomial degree 1 with a leading coefficient of 1. So it is very restrictive in terms of which divisions I can do with it, but when it is appropriate, it's very fast. Let's take a look at one more example. So here I've got 2x to the 5th minus 25x plus 26x squared plus 16x to the 4th minus 16 plus 29x cubed, all divided by 6 plus x. So just comparing this to our first example, everything is out of order. And that means that I need to put it in order first before I run synthetic division. So I'm going to start here. I'm going to put the dividend, this long polynomial, in descending order of exponents. So my highest exponent here is a 5. So I'm going to start by recording this as 2x to the 5th. Now I'm going to put it in the descending order. So my next term would be 16x to the 4th. Notice my power is just going down by 1. Next would be plus 29x cubed. Then plus 26x squared. Minus 25x. And lastly, minus 16. I also want to rewrite that divisor. It's switched around too, so I'm going to put divided by x plus 6. So now what I've got is a dividend and a divisor that's written in decreasing order of exponents, descending order. So now I'm ready to run the division. So I see that my division number here is going to be the solution to x plus 6 equals 0. So if I solve x plus 6 equals 0, that's going to give me x equals minus or negative 6. And that's what I'm going to place as my divisor number. Then I'm going to take the coefficients just as I did previously: 2, 16, 29, 26, negative 25, and negative 16. And you can see the importance of putting it in order. It really makes this synthetic division possible. It's got to be in order from highest exponent down to lowest. So now we're ready to run the process. So again, it's just as we did in our first example. I'm going to carry down the first value 2 and then multiply. Negative 6 times 2 is negative 12. Now I'm going to add 16 plus negative 12 is 4. And I'm going to multiply again. Negative 6 times positive 4, negative 24. 29 plus negative 24 is 5. Multiply again. Negative 6 times 5 is negative 30. 26 plus negative 30 is negative 4. Multiply. Negative 6 times negative 4, positive 24. Negative 25 plus 24 is negative 1. And my last product, negative 6 times negative 1 is positive 6. Negative 16 plus 6 is the remainder, negative 10. So for this division, my final answer is going to start with 2x to the power of 1 less than 5, so 2x to the 4th, plus, oops, I said 4th and wrote a square, plus 4x cubed, plus 5x squared, minus 4x, minus 1, plus negative 10, all divided by x plus 6. And that completes the division there using synthetic division. Well, thank you for joining for this investigation of dividing polynomials using synthetic division. See you soon.